For years, red lasers ruled the optical disc world. CDs used them, DVDs used them. But then came high-definition video and suddenly, red wasn't enough. To pack hours of HD movies onto a disc, we needed a laser with a much shorter wavelength, into the blue laser. But here's the twist. To competing formats emerged Sony's Blu-ray and Toshiba's HD-DVD. Both used the exact same blue laser, but they held completely different amounts of data. Blu-ray held 25 gigabytes. HD-DVD held just 15, same laser, different capacities. How is that possible? Let's dive in. To understand the leap, let's compare wavelengths. A CD uses a red laser with a wavelength of 790 nanometers. That's about a millionth of a meter. It would take over 300 of these beams lined up to cover the width of a single human hair. A standard DVD uses a slightly narrower red laser at 650 nanometers. That small reduction in wavelength allowed DVDs to pack data tracks just 0.7 microns apart, about half the spacing of a CD. Then comes the blue-violet laser at 405 nanometers. That's almost half the wavelength of a CD's laser. It creates a beam so thin the track spacing shrinks to just 0.3 to 0.4 microns. Think of it like this. A red laser is like a thick paintbrush. A blue laser is like an ultra-fine pen. The finer the tip, the smaller the details you can draw and the more information you can fit in the same space. Now for the puzzle. Both Blu-ray and HD-DVD use a blue laser with the exact same wavelength, 405 nanometers. The answer isn't in the laser itself. It's in how the data is recorded and interpreted and in the physical construction of the discs. First, let's understand how data is actually read. A laser reads the pattern of pits and lands on the disc surface. The critical moment isn't the pit itself, it's the transition between a pit and a land. Each transition represents a binary one. Before the information reaches your computer, the drive must demodulate it, a process that converts optical bits into real data bits. HD-DVD uses 8 to 12 demodulation. 12 optical bits are required to create 8 data bits. That's a lot of overhead. Blu-ray uses a more efficient encoding scheme, needing fewer optical bits to produce the same amount of data. But the most important difference comes down to something surprisingly simple: the protective plastic layer. On a Blu-ray disc, the protective layer is just 0.1 millimeters thick. This is incredibly thin. HD-DVD uses a thicker protective layer, 0.6 millimeters, the same as standard DVDs. Because the beam spreads slightly as it travels, the pits and lands must be larger and the tracks wider to be readable. Blu-ray sacrificed some durability to pack more data. HD-DVD prioritized protection over capacity. Just like the Betamax versus VHS war of the 1980s, a format war erupted. Movie studios were courted to pick a side. HD-DVD had one major advantage: the discs were significantly cheaper to manufacture. But in the end, factors like studio support, PlayStation integration, and consumer momentum pushed Blu-ray to victory. And that's the story of how a simple color shift from red to blue sparked a revolution in data storage. Thanks for watching.